dalam slide tu kan. So saya dah masuk sikit. Masuk sikit. Okay, siapa boleh explain in general what is linear and between linear and non-linear? Okay, ada yang boleh explain? Tak ada? Last time simple linear and multiple linear kan. Okay, just now we have linear. So linear, you all already know what is linear. Based on y the line equation, okay, y equal to mx plus c, right? So when we plot, okay, in graph, so we can get a linear relationship between our input and output, okay. Okay, but how about non-linear? Siapa boleh agak-agak, siapa boleh explain, okay? Boleh someone? Nolita, boleh. Okay, Nolita boleh explain? Nolita? Linear, what difference between linear and non-linear? Deviation yang tengok lagi, tapi just linear and linear, non-linear. So linear tu macam mana? Linear tu kita dah tahu is they have a linear relationship between input and output. Okay, kalau kita plot graph, dia akan ada equation y equal to mf plus c. Okay, m tu adalah slope, x tu adalah our input, and then so intersection, okay, at y-axis. Okay, but how about the non-linear? Siapa boleh ada general idea? Siapa boleh volunteer seorang? Okay, come on, come on. Mungkin saya boleh panggil siapa dalam ni? Zarif Kamal ada Zarif Kamal?
Ada sir.
Ada tak apa general idea about non-linear? What is non-linear?
Bagi pendapat saya lah, kalau linear ni data dia dalam straight line ni.
Straight
kalau
line
non-linear
dengan
data dia boleh belok-belok macam tu lah.
belok-belok
Dia tak apa? Dia tak linear lah, dia non-linear.
Okay, in term of mathematics, you jawab dari segi engineer sikit lah. Boleh?
In terms of mathematics, the data will look like a curve in graph, like that.
Okay, boleh give some example of curve in mathematics?
Cosine.
Okay, lagi?
Sine.
Lagi? Exponential?
Exponential boleh.
Sigmoid? Sigmoid. Pernah dengar? Sigmoid?
Tak pernah.
Tak pernah Logistik? Log?
Tu pun tak pernah.
Tak pernah?
Tak.
Okay, boleh explore lagi lah. Apa function dalam matematik tu. Okay, so tadi ada banyaklah function dalam matematik yang you can relate on the non-linearity. Okay, kalau kita boleh panggil is a non-linearity model. Okay, for example, tadilah sine wave itu sine wave ataupun exponential, okay, exponential function, sigmoid function, okay, and then ataupun you ada data yang actually we can estimate ataupun we can find the pattern of our data. Kalau kita plot tu, kita boleh tahu dia punya equation tu macam mana, objective function dia macam mana. Okay, itu non-linear.
Boleh sir.
Okay, kalau you tengok situ, what is a non-linear model? Is in general, in the regression model can be seen as a non-linearity of dependent variable lah. Kalau you all tahu variable tu apa? Variable tu adalah our input ataupun our attribute ataupun features. Okay, input lah, variable tu input. For example, what is a binary ataupun nominal, multivariate nominal, itu semua type of variable. Okay, and then dia ada dua, satu dependent variable, satu lagi independent. Okay, dependent means every variable depend each other. Okay, ada kaitan, ada relationship. Okay, and then independent bermaksud is not depend each other. So no relationship between variable, can be any value. Okay, without relationship. Okay, in between variable. Okay, yang tu clear. Okay, dependent and independent. Kalau you nak tengok contohnya kalau you have your age, okay, your age is your input, umur tu input. Your age is depend to what? Okay, so depend to what? Depend to your for example, in clinical test you have what? Age, and then you have a ketinggian, you have a apa? Dari segi kesihatan tu dipanggil apa? Ataupun dia punya blood glucose value, dia punya blood pressure value, dia punya heart rate, ada tak kaitan? Okay, age mesti ada kaitan dengan dia punya heart rate, contohlah. Okay, this is dependent. Kalau independent mungkin if we get example macam kereta, contohnya kereta apa? Okay, dalam kereta tu ada variable apa? Tayar ke apa kan? So adakah variable on the car tu is independent to others variable? Okay, so that's one depend on depend on the meaning of a variable lah. So how far you find the information of your data set, and then your variable is dependent or independent. Okay, okay, next. Okay, this one, how to detect non-linearity. Okay, you can detect the non-linearity based on what? Some information lah. Okay, you got the information from the data, and then you know that this variable, okay, is have a non-linearity relationship, okay, between variable and output. Okay, and then also you can plot. Okay, you have a data and then you try to plot. Okay, for example, you have iris. Okay, you just plot the input and then you can see data tu scattered macam mana. Okay, dia punya location of data tu dia apa adalah linear ataupun non-linear ataupun dia bertibaran dalam subspace tu. So ni satu cara. Yang lain tu apa tu? And then kalau if your data involve on seasonality, so for example agriculture, building industry, so involve on time, so you can see that macam gold price tu, dia ada season, someone they high, sometimes they slow, they low dia punya price, so you boleh tahu dia adalah in term of non-linearity ataupun dia linear. Next, so next kalau yang ni tadi, kalau you tengok graph, you plot the data, you boleh tahu this one is linear or non-linear. So macam ni very simple lah. For this one is very simple. This is what? Linear kan? The data is plotted in linear between X and Y. Y is our output, X is our input. Kalau kita plot graph, dia akan dapat linear line. Yang ni this one kalau kita non-linear. Yang ni pun sama. This is non-linear. And then this one also non-linear. So actually our data, our data yang non-linear ni, this one, we can transform to be linear, by using this function lah. For example, exponential function, we transform our data, non-linear data tu to become a linear. Between a range lah. So for example, like this is a equation, so we can use a logarithm ni, for exponential function, to convert our non-linear to linear model. And then the other function is logarithma, and then we can use power function, to convert our non-linear data to linear data. And then we can use logistic function, yang ni, this one, to convert our non-linear data to linear data. And then we have hyperbolic function. Ini semua dalam matematik. This one in on matematik lah, function dalam matematik. So they are several function that we can use, to convert or transform our non-linear data to linear data. Somehow we need this because if we evaluate or we observe our data is too non-linear, it will lower grade the performance of our system. That's why we need to transform our data to be from linear to linear. This is one of approach in the transformation. Alright. Sekejap stop dulu. So in Google Classroom, so you can find example of coding based on Python. Okay, and then don't forget to fill in your attendance today. Okay, so you can find this one. Okay, basic understanding of nonlinear too. You can try. Okay, I will explain. Okay, this one. And then they have one example on nonlinear regression. Okay. Okay, so this is a basic understanding of nonlinear regression. Okay, so regression you already know is a supervised machine learning, and then they have independent variable and dependent variables. Okay, on the basic of relationship between variable, and then we can you can create your own example, your own data like X is one. Okay, and then create your own package. Okay, and MATLAB by this one using NumPy and Pandas, and then plot visualize using MATLAB library. Okay, then X is we create our own data. Okay. Okay. Okay, done. Okay, then this one they add some noise. Okay. And then this is example of linear, right? Okay. This is example of a linear model, okay, of data, where y equal to mx plus c, and then we can manipulate this data, okay, to make non-linear, okay, like this, just to show you how non-linear data looks like. Okay, so as you can see that the red line is not straight line. Okay, not y equal to mx plus c. Okay, there is some noise there, and then plot. Okay, and then this one is this one perfect nonlinearity. Okay, so we can generate like this. Okay, so our data is nonlinear lah, right? Like this. And then this one is okay, example logarithm, okay, function. Okay, our data can look like this. Okay, logarithm, and also exponential. Okay, this is exponential data. Okay, exponential. This is non-linear model based on exponential. Okay, so our data is exponential types. Okay, and then also this one sigmoid. Okay, and then our data also can be sigmoid. Okay, like this. All right. Okay, so you can explore yourself based on this code. And then next example. Okay, everything why? Clear tak? Boleh
Yes,
nampak?
sir.
Okay, so you pun boleh open, okay, your collab sendiri. Okay, so this one we start with example, okay, by using the given data set. Alright, so they have a step, okay, starting with starting with download the data, okay, and then uh, they have a objective function there, okay. So saya akan tunjuk, okay, this one, okay, same thing, okay, you create your packaging and class, and then this one is okay, you can find your data, okay, and then this is your input, okay, ym is your output. Okay, let's say we can try to read, okay. Betul ke macam ni nak display data? Ya. Okey, siapa ingat nak display data macam mana? Command dia? Siapa ingat? Okey. Hai. Tak boleh tak? Ke DF? Ha. Okay. Okay, this one example data. Okay, kita just take 10 sample. Okay, this one year 2000, month, and then okay, input dia ada berapa? 1, 2, 3 input, and then output dia best price. Okay, best price. Ini price apa ni? Price minyak oil data, harga minyak. Harga minyak. Okay, so macam mana nak plot ya? Cuba try. Boleh bagi command tak? Boleh bagi code. Macam mana nak plot this one? Okay, macam mana plot? Kita nak plot data supaya nak tengok data ni linear ke non-linear. Tu ada example. Data kalau ni input satu je. Okay, this one input only. Okay, try buat input je lah. Okay, macam mana? Siapa ada idea? Okay, macam mana nak ambil WTI price ni dengan best price? Macam mana? Boleh bagi idea? Sama-sama. Okay, sekarang saya nak ambil data WTI price dengan best price. Itu je. So, kita akan plot, tengok dia linear ke non-linear. Apa nak buat dulu? Siapa boleh, you all boleh try You all ada kan koordinat? Boleh try. Okay. Sekejap. S1. This one X M. One. Okay. So YTI price dengan best price nampak macam linear. Alright. And then kalau SM2 SM2 tak linear. Okay. And then input ketiga tu NGL price. Okay. Agak linear tapi ada outlier. Macam itulah you baca data. Okay. So far okay, boleh follow? Senyap ini. Okay, boleh follow?
Boleh, sir.
Okay, right. Okay, so after you dah kenal pasti every variable tu, linear or non-linear, so you boleh, actually non-linear ni can be run as a single variable or multi-variable. Okay. Okay, this is your equation. Kalau you tengok kat sini, you nampak yang atas hijau ni adalah line equation for linear. Okay, y equal to A times SM1 plus B. Okay, ini linear. Okay, so A adalah apa? A adalah slope, B adalah coefficient ataupun intersection. Okay, then you nak apply non-linear punya equation. So this one, okay, A times AXM1 ni power of B, and then times SM2 power of C, and then times SM3 power of D. Okay, so okay, so kalau macam ni, ini dia akan we create function, So you boleh try kalau you tak faham aku masuk ni. Code tak atas lah. Okay. So you try run. One error. X is not defined. Oh, okay, okay. So this one dia apa? Dia create function, okay, untuk calculate y, and then dia calculate function untuk calculate objective function, okay. Y ni equation ni lah, okay. Y ni equation ni, okay. Objective function dia adalah this one, okay. This one. Ini formula untuk objective function. Kalau you tengok kat situ, yi ni apa? Yi ni apa? Yi ni adalah kita punya predicted. Okay. So, predicted output. Ym ni adalah kita punya actual output. Okay. Faham tak? So, formula dia macam ni lah, objective function. Okay, so dia akan okay. Ada yang tanya? Ada ya?
Ada sir.
Belum. Okey, yang mana actual output? Actual output this one lah, daripada dataset. Okey. Yang mana predicted output? Predicted output adalah daripada kita buat regression punya apa? Proses ni. So we predict the output and then kita minus dengan actual output, dapatkan dia punya error value divide by actual output. So itu formula dia. Okay. So proses dia, okay, first you create data and then next kita akan this one kita akan buat initial punya proses. Okay. Maksudnya kita akan put the initial value of x ni, okay, x0 ni, okay, and then selepas itu kita akan buat optimization, okay, by using this minimize punya function, okay. So dia guna method SLSQP. Okay, nanti kita tengok apa itu SLSQP. Okay. Okay, ada tanya? Okay, what the purpose kita nak buat minimization ni? Apa purpose dia? Ataupun what the purpose we do regression? Okay. Siapa boleh can answer the question? What the purpose we do regression on the data? Boleh nampak tak? Mimi. Mimi ada Mimi? Mimi ada? Jawab ni. Mana Mimi? Mimi Najiha. Mimi Najiha ada? Hey, you all ni attend kelas ke just letak phone? Pergi toilet pula. Tadi saya panggil dia pergi toilet. Okay. Ainul. Ainul, boleh tak jawab? Kenapa, what the purpose we do regression? Kita ada data set and then kita tahu data tu linear ataupun non-linear. So at the end, apa yang kita, selain kita dah dapat prediction punya output tu, apa lagi yang kita boleh cari? Apa yang kita nak? What the purpose? Okay, siapa nampak?
Sir, supaya kita boleh predict apa yang
okay, predict tu application. Kan, kita ada data and then kita learn from data and then kita nampak trend. Okay, and then kita predict. Okay, Anu cakap predict, itu application. Okay, application. Kita nak buat benda tu. Memang kita nak buat benda tu. Tapi dalam tu apa sebenarnya? Macam mana kita nak dapatkan prediction tu? Apa sebenarnya yang kita nak cari? Okay, ada yang nampak tak? Okay, predict value tu betul. Pattern tu betul. Okay, kemudian pattern tu betul. Apa lagi yang paling penting? Dari segi kalau you boleh relate dengan teori. Okay. Okay, classification tu method. Okay.
For estimation.
Yap, Abdullah.
For estimation.
Understand the minimum value. Okay, hampir tepat lagi. Siapa boleh agak? Who can see what the main purpose actually? Kalau you relate dengan teori tu. Okay. You ada data and then you plot macam kita buat tadi, kita plot and then we will see the pattern of the data every variable, okay, that have relationship with the output, okay, either non-linear or linear, okay. Estimate the data. Okay, lagi habis our regression have minimum error or not? That one, the output, the performance, okay. Itu yang guna objective function tu, okay. Apa lagi? Okay, boleh agak? The accuracy is output. Lagi, the performance. To see which product is in demand. Estimation, okay. To general, Abdul Ghazir. That one, method to general. Ada lagi. Relationship between dependent and independent variable. That one, we have plot and then we can observe the relationship, okay. Dependent, either variable is dependent or dependent, okay. Ada lagi. Okay, how you relate with the equation y equal to mx plus b ataupun the non-linear equation tu, how you can relate? Okay, jawapannya ada dekat equation tu, equation line tu. Okay. Okay, so at first, okay, at first we plot right, like this one. Okay, betul tak? Kan, kita plot data kan, we plot the data, but we don't know the equation of the line, betul? Ada jawapan ni. Okay, relationship, alright. Hampir tepat, Abdullah. Siti Zahra, relationship between two variables. Kita tak tengok relationship, kita tak tengok correlation tu, kita tengok one. Okay, they want the relationship between two variable is correlation. Okay, this stage kita tak tengok. Okay. Okay, so okay, the answer is okay. At the first stage, okay, you plot kan, you plot and then you tengok this one is most likely linear lah, okay. But you don't know the equation of the line, okay. Betul tak? Okay, to see if we can formulate within y and x, okay. Alright. Okay, so actually the main purpose is we want to find the equation of the line. Okay, so that's every data have because the line is the actual output. Okay, the line is the best fit line that suit to our data. Okay, kita akan guna that line. Kalau you if you remember that we will calculate the R squared kan, R squared tu. Okay, R squared is our performance. Okay, so we have to find the reference. Okay, the best line or the best fit line. Okay, so that we can calculate the performance. Okay, that's the purpose of regression. So we have to find the best fit line. Okay, alright, understand? Faham tak? The keyword is best fit line, line merah tu. Okay, faham tak? Okay, that's why at first, okay, kalau you can see this coding. At first, we have decide the equation for y. Okay, for example, now we use non-linear equation. Okay, like this. Okay, so we decide we use non-linear equation. Okay, because they are using what more variable. Okay, 1 2 3 SM1 SM2 and SM3. Okay, so 3 variable, right? Okay, so after we decide, okay, which equation that we will use, okay, for example, this nonlinear, so we have to find the variable of, not the variable, the parameter value of A, B, C, and D. Okay, this four value A, B, C, D is unknown value. Okay, unknown value. Understand? Faham tak? Respon sikit.
Faham, sir.
Okay, A, B, C, D is our unknown value. So we have to find the unknown value so that it can complete or it can fulfill our equation so that we can draw the line. Okay, play. Just now we don't know the value of A, B, C, and D. Okay, we just assume that this data is non-linear. Alright, so that's why we use this equation. Okay, y equal to A ms1 b power of b sm2 power c sm3 power d. Okay, that's why. Okay, and then this, okay, so you can see the next line is objective. Okay, objective is objective function. Okay, define objective means we calculate the this one, the error, okay, between our predicted output and actual output. So we find, okay, so after we put any value of A, B, C, and D, okay, kita dah letak apa-apa value yang dekat initial state, so kita letak kosong contohnya, and then kita boleh calculate objective function. Okay, bila we calculate objective function by using the equation of y, we can calculate the objective function. So we can see that our line is best fit or not, okay, to our data. Itu maksudnya. Okay. So kalau you boleh tengok coding ke sini, kalau you can read this code. Okay. So at first we set our x, okay, our this one, okay, SO, S1, S2, S3. Okay. This one is our initial value, so we set to 0 first. Okay. Alright, we set to 0 first. Okay, and then this one print initial objective equal to objective at 0. So kalau you tengok kat situ, okay, lepas dia masuk 0 tu, our value become, this is y value lah, 153.0. This is our initial objective. Okay, 153.0 dia calculate. Okay. Okay, so objective dia dah calculate y, and then dia calculate y first, and then barulah boleh calculate objective. So value dia tadilah 153. Okay, so next is they use minimize function ni. Okay, they use minimize function, okay, to find the new x. Okay, to find not new x, to find the new solution. Okay, new solution. Okay, so between this range, okay, 0, minus 100 and 100. Okay, then they calculate the y again. Okay, and then after calculate y, they calculate the objective again. Okay, so they find the new objective and then print solution. So at the end, daripada minimize function tu, dia akan dapat the optimized value of A, B, C, and D. Okay, so if you can see the output, okay, A, B, C, and D. Okay, this one, A equal to 1.044, B equal to 0.97, C equal to 0.02, D equal to 0.022. This is optimal value of A, B, C, D. Okay, that we can get R2, R squared correlation is most close to 1, means the good, okay, performance lah. Okay, alright, boleh tak? So kalau you boleh draw balik line tu using this unknown value ABCD, you boleh draw balik, and then you can do predicted, okay, balik against. So your predicted value will close to this line, okay, Y line, okay. Okay, boleh faham tak? Can understand? Boleh? Respon sikit?
Boleh sir.
Okay, so yang tadi minimize function tu, minimize function actually to find the optimum value of our unknown parameter A, B, C, and D. So macam magic lah, okay. Dia akan by using a mathematical equation, okay, the minimize function, we can automatically know the optimum value of our unknown parameter A, B, C, D, so that our data is can our line tu can be at the best. And then if we have new value, okay, let's say we have a new data that we don't know the output, the price, okay, for example yang SM1, SM2, SM3 kita ada new value of price, kita nak predict the price again, so we can use the Y equation, okay, equation, and then we put the optimum value of ABCD to our Y equation, and then we can get the predicted Y. Itu cara dia. Okay, boleh faham? Can understand the basic concept of regression?
Can sir.
Right? Boleh?
Boleh.
Okay, if you can understand the basic concept, if you given any kind of data, then you can generally understand, okay, the process and the step. Okay, right. Before we going deep on the mathematical equation, or because they have many type of model, okay, on the regression. Ada banyak model. Model tu is a mathematical model lah. Okay, macam tadi logaritma, sigmoid, apa lagi? Exponential, okay, macam-macam. Okay, many methods. Gradient descent, many methods. Okay. Okay. Okay, so next, kalau you nak tengok lagi method ni, okay, method ni kita boleh try find the definition of this. Okay, sekejap . Okay, sekejap. Okay, we break kejap, 5 minutes, so we just try the code. Okay, so actually they have many methods, okay, for optimizing the unknown parameter. Okay, yang we just use now is tadi SLSQP. Okay, so you can find this one. Okay, SQP is sequential least squares programming. Okay, so you can actually you can change. Okay, for example, using, let's say, Newton CG. Okay, so just copy and then change to your code and try to run again. Boleh tak? Okay, so ada banyak method ni. Okay, okay, so you can try. You can try one by one. Okay, satu-satu je boleh try. So, okay, So kalau tak sesuai, dia akan keluar macam ni lah. Okay, and then you kena modify. Okay, so saya rasa tu saja saya tunjuk. Okay. Any questions so far?
Nak tanya, tadi SLS tu nak minimize dia punya value sajalah, sir.
This is optimization method. Okay. The purpose is to find the optimal value for our unknown parameter.
Oh.
Kan kita, we have an equation y equal to mx plus c. X kita tahu. Non-linear kan. Yang SM1 kita tahu, SM2 kita tahu, SM3 kita tahu. But A, B, C, D itu yang unknown parameter tu kita tak tahu. Initial state we can put any value. Okay, like they say 0 value for our unknown parameter. Then we let it the optimization method tu, okay, minimization method, okay, to find the optimal value, okay, for our unknown parameter ABCD tu. Okay. Okay, faham?
Faham, sir.
So at this stage, when we do the non-linear regression, so step dia macam ni lah. Okay. We have to apply objective function. Okay, yang equation predicted output minus actual divide by predicted output. Okay, yang saya tunjuk tadi. Mana tadi? This one. Okay, objective function. So kalau you tengok dekat mana-mana teks pun, dia akan keluar benda yang sama. Dia akan tunjuk benda yang sama lah. Okay. Sekejap Okay, saya tunjuk satu paper ni yang menerangkan tentang regression. Jadi, okay, nampak? Nampak tak?
Nampak, sir.
Okay. Paper ni is a non-linear regression analysis by using experiment data and then Microsoft Excel. But we use Python, sama je. So, I just want to find the information lah. Okay, sekejap saya tunjuk But the same thing actually. Okay. Okay. This one. This one is wait. This is equation lah. Okay. This one equation yang dalam slide tu. Okay, this one equation for R squared. You boleh pakai. Okay, direct equation And then for non-linear equation. Okay. Objective function ada. Okay, kalau you baca any method on the linear, the basic concept dia macam dalam code tu lah. Okay, but they can use different function lah. Okay, this one example. Okay, mana lagi? Sekejap. Okay, satu lagi saya nak tunjuk, ada satu website ni. Okay. Okay. Okay, boleh nampak this one? Okay, sekejap saya copy dia punya link. Okay, you can gain more understanding. Okay, so this one, okay, for example, we go to documentation. And then we go to, okay, siapa yang nak belajar basic Python, dia boleh start kat sini lah, kat website juga. Okay, Python, MATLAB, Java. Okay, contohnya data science ni, so ada video kat situ. So yang point 1 to 3 ni saya dah explain lah. Okay. Okay, let's say regression. Okay, you can keluar GitHub. Okay. Okay, so you can see this one is the objective function, okay, to minimize. Okay, you can also use this one. Equation yi minus zi power of 2. This one is a loss function, dipanggil loss function. Okay. So sama je, first you kena ada input y. Okay. And then output measurement is the predicted. Okay. Y is actual, Z is a predicted output measurement. So okay, jadi linear okay. Okay, this is non-linear. Okay, kalau you perasan tadi equation dekat coding tu kan, betul tak? Tapi tak ada cos ni. Oh, bukan. Okay, tak apa. Okay, so you can go through this website juga. Okay. To gain more understanding, okay, about the deviation. So yang best kat sini, so you can dia ada web base. Sekejap this one online. So you boleh guna this one lah, okay, web base to code. Tak payah download. Ataupun sama je macam collab tu, okay. Okay, so saya rasa tu saja untuk saya tunjuk hari ini kelas. Ada apa-apa soalan tak?
Tak ada, sir.
Data analytic, data science sama je lah. Data analytic tu data science lah. Okay. You confused lagi data science tu data analytic lah. Ada apa? Dia actually depend on your level. Okay. Actually data science and analytic sama je. Tapi content dalam tu actually banyak kan, content dalam tu banyak. So different syllabus, different content, itu je. Okay, kalau you more deep on data science, dia akan ada banyak lagi sampai ke cloud, sampai ke IoT, sampai ke different platform. Betul tak? Okay, dia macam itu je. So, but basic pun dah banyak. So you boleh imagine lah kalau you nak pergi more advance tu macam mana. Okay. Tapi basically yang saya introduce itu data analytic, data science in general concept yang you kena tahu tu lah data, and then make sure you boleh observe data tu. Okay. You tak perlu involve on data collection pun. Okay, tapi kalau we as engineer sikit banyak kita kena tahu jugalah sebab data tu come from dari mana. Okay, tu kena tahu sebab kita nak get information, nak observe variable tu adalah ada any relationship ke tak. Okay, kalau tak kita boleh guna cara tadilah, correlation ataupun visualize and then observe the linear analytic supaya kita dapat lot of information of data and then we can choose the right method. Okay, so itu yang penting. So first, dalam data science yang paling penting tu adalah of course data, so you can observe and then get information, and then next is data transformation lah, how to transform, okay, from the categorical data to the continuous data, gitulah. And then macam kita dah buat last class, okay. And then the next step is dalam data analytic or data science, the basic method yang you kena tahu adalah clustering. Okay, what is clustering? Okay, kita baru sentuh satu method lah, K-mean. Itu baru satu method. Okay. Dalam dunia ni ada berpuluh-puluh method clustering. Okay, dia combine sana, dia combine sini, dia tukar equation sana, dia tukar ke sini jadi satu algorithm. Dia ada banyak. Okay. But the basic concept clustering, you kena tahulah. Okay, clustering tu apa sebenarnya. Okay. And then at least you boleh apply one of two method. Contohnya K-mean ataupun K-n dalam clustering. Itu salah satu. Okay, next is a regression. Okay. You kena tahu, you have to know is definition of regression lah. What is regression actually? Okay, what data that can use regression? Okay, you tak boleh guna data yang output dia binary ataupun categorical to do regression, tak boleh. Okay, and then macam saya tanya tadi, what the main purpose of regression actually? So to find the best fit line. Okay, because we just know our data, okay, and then scattered, okay, in the various location, but we don't know the best fit line, okay, of our data. Okay, supaya kita on the predicted stage, we can use the line tu, equation line tu untuk predict kita punya output. Okay, nak dapatkan line tu, equation tu, and then kita dah dapatkan optimum value whatever equation yang kita pakai untuk line tu, then kita boleh predict punya output. Itu cerita lah. And then next stage you akan involve on features. Okay, you ada many features, you ada many variable, many attribute, and then how we select the most relevant features or variable. Itu dalam data science data analytic. Okay, method. And then next stage is classification. Okay, regression tak sama dengan classification. Okay, alright. Regression we predicts the output, okay, based on the line yang kita cari tu. Okay, but classification, okay, we predict the class output. Okay, so but contohnya we have 0, 1, 0, 1, 0, 1. So we could predict which one 0, which one 1. Okay, kalau regression output dia lebih kepada discrete ataupun continuous output. Okay, but classification output is categorical. Okay, color, okay, ataupun binary, okay, is categorical. Itu different, regression and classification. So dia dalam satu syllabus data science lah, data analytic. Okay, so nanti bila dah habis semua, you kena evaluate dulu the performance. Okay, you starting dengan method yang you dah buat, you dah proses cleaning, transformation, you dah buat regression, classification, and then you kena evaluate pula method yang you pakai tu. Okay, accuracy tu lah yang you cakap tadi kan, accuracy tu either dia in between 90% ke ataupun close to 100%. Okay, of course kita nak cari method that close to 100% accuracy. Itu our target lah. Okay, after we decide, okay, the best method we use in our system. Okay, so dia besar kan, satu benda yang besar. Okay, platform pun satu juga. Okay, okay, platform dia ada Python, C, C#, Java, HTML pun kalau you involve web based, so ada banyak. Okay, so itulah dia. Okay, part of data analytic ataupun data science. Okay. Okay, so saya open lagi question, ada yang tanya tak? Mungkin you all ada terbaca ke kat mana-mana? Okay, boleh tanya lagi apa-apa? No question. Okay. Okay, next week test Jangan lupa 13 kan? Okay, next week test jangan lupa. Hari ni pun tak semua datang ni. Okay, so soalan tak? Nanti jangan lepas test boleh tanya.
Sir, test ada soalan sampel ke sir?
Tak ada.
Ada.
Soalannya you kena program.
Semua program lah sir.
Adalah sikit.
Teori ada sir. Teori.
Teori ada.
Ah.
Test up to clustering Deviation tak masuk sebab you boleh belajar minggu ni. Okay, daripada awal data and then variable data tu and then mungkin ada data transformation, lepas tu coefficient, correlation yang metric tu, and then up to clustering. Okay, Kemin. Okay?
Okay sir.
So kalau you buat assignment tu, you boleh jawab lah. Assignment macam mana assignment? Dah start buat ke? Belum start buat lagi ke? Atau baru nak cari idea?
Hari ni dia nak buat start.
Baru nak buat. Okay. Kenapa you risau pasal test? Saya pelik betul lah. Even FYP pun, you sibuk dengan markah rubrik tu. You sibuk dengan assessment you all. Tersangkut dalam clustering. Apa assignment ke? Sangkut. Okay, sangkut kat mana? Saya tak tahu you boleh solve ke tak. Kalau tak, datang discuss lah. Okay. Tapi kalau time deadline tu mau nak discuss, payahlah. Right? Semua ada sini kan? Semua ada campus kan? Yang mana ada campus, you carilah peluang, okay, untuk kita discuss. Ada yang dah complete ke assignment? Assignment 1 tu? Assignment 2? Okay, so bila you tak ada, mungkin you baru nak start buat ke apa ke, you lambat buat, you lambat lah jumpa masalah tu. Okay. And then bila you lambat jumpa masalah, you tak tahu you punya you punya weakness kat mana untuk di improve. Okay, you start kan. At least kalau you tahu you start kat mana and then you datang discuss, at least you boleh solve the problem tu. Itu je. So kalau you start lewat, hari Ahad, hari Sabtu baru nak buat, saya dah tahulah jauh mana you boleh siapkan assignment tu. Okay. Right. And then kalau, yelah, saya pun tak tahu online kan. Okay. Tak boleh nak tengok muka you all pun. And then saya pun tak tahu you all ada ke tak kat dalam ni. Okay. Ada kan? Yang respon tu adalah yang lain tu kan ramai, ada 35 orang. Okay. Okay, so okay tak? Saya open question ni, ada dalam mungkin 10 ke 5 minit. Open to the question, apa-apa, any question? Tak ada Kalau tak ada, saya nak bagi assignment kot. Boleh tak? Assignment 3. Ada soalan ni.
So, tapi assignment 3 tu bila nak hantar? So, let's say saya bagi hari ni.
Assignment 3 next week lah, seminggu saya bagi. Lepas test.
Oh, lepas test.
Hilang soalan ni, ya. Okay, sampai-sampai tu kalau terfikir soalan, tanya lah. Okay, so apa dia ada soalan? Tak ada soalan. Okay, so lepas test tu saya bagi assignment 3. Test hari Selasa, hari Khamis depan. Okay.
Okay, sir.
Sir, tanya, yang test tu still face to face lah?
Online.
Online? Okay.
Okay, online open book. So you kena guna kod lah. So you boleh cari apa contoh-contoh coding tu and then modify untuk jawab soalan. Itu je. Okay, boleh? Okay, so kalau tak ada apa-apa, kita stop dulu. And then don't forget our test, midterm test tu next week, hari Selasa. Okay, pukul 2. Okay.
Okay, sir.
Okay, thank you. Okay, jangan lupa attendant. Attendant jangan lupa.